Welcome back, mathematicians. In this video, we'll tackle three big ideas. First, how to simplify a rational expression by factoring and reducing. Then, how to multiply two rational expressions. And finally, how to divide them. Each problem will build on the last one, so you'll see how the skills are connected and also how to use the same factoring tricks in all three situations. By the end of this lesson, you'll know how to take what looks like a really complicated fraction like this with polynomials and break it down into something much easier to work with. Don't forget that I usually include free practice worksheets with my videos. This one happens to have two different free practice worksheets, so check out the links below in the description. Now let's dive right in. So the first thing that I like to do when I'm looking at these problems is actually to think about them as two separate problems. I like to pretend that the denominator does not exist at all while I'm working with the numerator, and then I do the same thing when I work with the denominator. So right now we are only going to look at 9x squared minus 25. I like to also think about my factoring rules. What kind of quadratic is this? This happens to be a difference of two squares. Knowing that it's a difference of two squares, I'm going to think to myself, what do I do when it's a difference of two squares? And in this case, we're going to factor it into two binomials, split the x, split the 4, and one becomes positive and one becomes negative. So this is my little reminder for myself. When I look at this, it's a little bit more complicated. The 9 has to be split into 3 times 3. So every perfect square here has to be split. X squared splits into x and x. 25 splits into 5 and 5. And 1 becomes positive and 1 becomes negative. Now I have fully factored the numerator. It's time to move on to the denominator. The denominator is a little bit more tricky. It's not a difference of two squares, it's not a grouping by factoring, and it's not an easy quadratic to factor where the leading coefficient is just 1, right? As if we didn't have a 3 here. Instead, I have a prime number as the leading coefficient, and I cannot factor it out of the rest. So in other words, 10 is not divisible by 3, and neither is 25, so I know I'm stuck with the 3. I can't get rid of it. Since I'm stuck with the 3, and since it's a prime number, I'm going to go ahead and write out my binomials with 3x in the first binomial and x in the second binomial. I know this can't change because 3 times 1 is the only way to make 3. So the thing that's variable is that 25 at the end. Now, a lot of these problems, I'm going to tell you, you can kind of find a trick from the numerator because this is a simplifying expressions problem. So they're going to want me to be able to simplify something in the numerator. 25 can be made with 1 and 25 or 5 and 5. So with that clue, I'm going to go ahead and turn it into 5 and 5. The thing I don't know is it 3x plus 5 or 3x minus 5? So I'm going to look to that middle term, of course. 3 times 5 is 15. 5 times 1 is 5. 15 is the bigger number. So 3 times 5 is 15, 5, and I know I'm going to be subtracting these. Since 15 is bigger and the 10 is negative, that means that I need the 15 to be the one that's negative and the 5 to be positive. So it's 3x plus 5 that I am simplifying. Remember that anything over itself is 1. So if you have x over x, you can cancel it out to 1. 2 over 2, you can cancel it out to 1, and that means that 3x plus 5 over 3x plus 5 is also 1. So we can cancel both of these out, and your final answer is 3x minus 5 all over x minus 5. Let's move on to multiplying expressions. So like I said, I like to think about numerators and denominators separately. This has two fractions, and so therefore we're going to break the entire problem up basically into 4 parts. I'm going to deal with the numerator, the denominator, the numerator, the denominator. Doesn't really matter what order. You can also see that I've shifted my problem over here and I've written it a little bit smaller so that I have more room to work because this is going to be more complicated. The other thing I like to look at before I begin is how I am going to factor these quadratics. So this first quadratic, again, is a difference of 2 squares. I know that's a perfect square, and I know this is going to be 3 times 3. In fact, I need to even make my marker smaller so that I have more room. The other 3 quadratics are standard, regular, leading coefficient equals 1, which are the more easy style of factoring quadratics. So I'll tackle those when I get there. Knowing that this numerator here is a difference of 2 squares, I'm going to go ahead and set up my multiplication sign and my 2 fraction signs. And I'm going to start off by splitting up that x and then splitting up the 3, making one positive and one negative. So far, it's exactly what we've done in the previous problem. So now we're going to factor this one as well by splitting up the x's. Splitting up the x's is the only thing I can do. 6 has factors of 1 and 6, and 2 and 3. Everything's positive, so I know it's going to be positive. And 2 times 3 is 6, and 2 plus 3 is 5. And I've done my first denominator. Let's pick another bright color. So for this numerator, again, I'm going to split up those x's. The number 3 is really easy to work with. It's only 1 times 3. Everything is positive, so I know everything has to be positive. That was almost a gimme. And I'm done here. And let's do one more. Maybe orange. We're going to split up those 2 x's again. Negative 15 is a little bit trickier. Because it's negative and because the center is negative, one of these is going to be positive and one of these is going to be negative. I know that because a positive times a negative makes a negative. And then when I subtract, the bigger number needs to be negative so that the center turns out negative. The factors of 15 aren't too complicated. They're 1 and 15 and 3 and 5. Since I know I'm subtracting, I must be using the 3 and 5 because the difference between 3 and 5 is 2. Again, the bigger number has to be negative in order for that to turn out to be a negative 2. And here's where I can start to simplify. Now, the trick with multiplying is actually that you can pretend like it doesn't exist at all and you can just squish everything together. So it doesn't matter if it's lined up directly here. This x plus 3 could cancel out this x plus 3. We have another x plus 3 and another x plus 3 here. As long as one is in the numerator and one is in the denominator and you're multiplying, it's really just a bigger simplifying problem. We don't have to do anything different with multiply except pretend that it's all one giant problem. Now that I know that, and I have removed all of these factors, I can simply write it back together the way it was before. So we have x minus 3 and x plus 1 all over x plus 2 and x minus 5. Now, some teachers are going to have you leave it in its factored form, like this. In fact, I would say most teachers are. And some teachers are going to have you multiply it back together and leave it in its quadratic form. To do that, we would multiply x times 1 minus 3 makes negative 2x, minus 3. x times x is x squared. Negative 5, positive 2 makes negative 3x minus 10. And so this is the factored form of the answer, and this is the quadratic form of the answer. Like I said, most teachers are going to have you leave it in its factored form. And finally, we have one more problem that is division. So, as you know, the first thing I like to do is to think about my numerators and denominators separately. We have 4 different separate factoring problems to do here, and then I notice that we have division. I like to get rid of the division first. Here's what that means. Remember that if you're dividing any fraction, let's say 2/3 divided by 1/5. Dividing fractions means you are going to multiply with the reciprocal. Remember, we turn division to multiplication and we take the reciprocal of the second fraction. This is dividing any fraction, and that really does mean any fraction. So to get rid of this division symbol, I'm going to rewrite this problem first. The first fraction stays exactly the way it is, and then you multiply with the reciprocal. The reciprocal means that this denominator gets moved up and this numerator gets moved down. They flip. Now I can begin my actual factoring. This first quadratic is a difference of 2 squares. We've seen this one before. We know what this one is. Pretty easy. And I'm going to go ahead and set up my fraction with multiplication between it. And that one's done. This one has our y's separated. And I just realized I wrote x's instead of y's. Let's fix that. The factors of 6 are 2 and 3. Everything is positive. And so this one's done. This is another difference of 2 squares. So I know it's going to be 1 positive, 1 negative, all the squares broken up. And finally, separate out those y's. We have negative 15, and this time the 2 is positive. So we're going to do a positive 5 and a negative 3 this time. And now we're ready to see everything that's going to cancel. Remember that we can think about that multiplication symbol as just one long fraction sign with everything squished together, so it doesn't matter where things are. Anything that's on the top and the bottom that's the same is going to cancel. So I'm going to start right at the very beginning. Y plus 3, does that exist on the bottom? It does, right here. Y minus 3, is there another one on the bottom? There is, right here. Y minus 2 does not exist on the bottom, but y plus 2 does. And this leaves me with a very simple expression when I'm done. It leaves me with y minus 2 on the top and y plus 5 on the bottom. This is its fully factored form, and there isn't another form to turn it in as. Before ending, I just want to make one note about factoring. I used 3 different factoring methods in this video. Difference of 2 squares that we see up here, factoring when the leading coefficient is 1, which you will not see the 1, it's implied, and when it's greater than 1, like this 3. If you're good at factoring, and there's a couple of other ways to factor I didn't cover in this video, this lesson is very easy. But if any of this factoring was confusing along the way, I would go back and practice quadratic factoring. Make sure to check out my Factoring Quadratics series in the Algebra 1 playlist. There are videos and free worksheets for that as well. You can go practice your quadratics and then come right back to this video and do the practice worksheets that are below in the description. Good luck, mathematicians!